To study momentum, we often look at collisions, and so we're going to look at a elastic collision with two carts of equal mass. So if you can see on the track in front of you, I've got two carts, two green carts, both of them at equal mass. And what we'll do is we will look at what happens if the cart on the left collides into the cart on the right and they bounce off of each other. So there's little magnets in these carts up here that allow them to bounce off of each other without actually damaging the cart. So observe what happens. The cart that you see now is at rest, and the next cart will be coming in to the right and cause a collision. So you want to observe what happens to the cart that moves, what happens to the initial colliding cart, and see what we can notice. So here we go. And we noticed a couple of things. Again, one cart moved in, the other cart was at rest. Afterwards, the initial cart stopped, and the cart that was stopped began. We want to be able to look at this situation from a momentum point of view and do some calculations. So it's typical for us to sketch out the problem. So let's look at that problem. Before the collision happened, I had two cars. Both of them were equal mass. Let's say, for the sake of this exercise, that they were each 2 kilograms. Right? So we have a 2 kilogram mass and a 2 kilogram mass. Initially, the one on the right had a velocity of 0, and the one on the left had a velocity of 5 meters per second. What happened was the 5 meter per second one was moving to the right, and the 0 velocity one was at rest. So this is our picture before the collision. After the collision, we saw a different situation. We saw the same two cars, but in this case, both 2 kilograms still, 2 kilograms. In this case, what happened is the initial car was at rest. It stopped, and the second car had a velocity. And the question is how fast was that thing going? So let's actually do a calculation. This is a conservation of momentum kind of problem. We know that conservation of momentum tells us that the momentum for this entire side of the collision, this is the before the collision side, is equal to after the collision. So if we're looking for momentum before and momentum after, because of conservation of momentum, we could say that these two are equal. So let's do some calculations. Momentum before is going to be mass times velocity for the first car plus mass times velocity for the second car. And since we know everything, we can plug in all those numbers. So it is 2 kilograms times the velocity of 5 meters per second plus 2 kilograms for the second car times 0 meters per second, which means that our total is 10 kilogram meters per second plus 0, or just 10 kilogram meters per second. That is my total momentum for both cars before the collision. If I want to look after the collision, I can do the same thing. Momentum after the collision is mass times velocity for the first car plus mass times velocity for the second car. And we can again plug in what we know. It is 2 kilograms times the velocity of the first car. Now we noticed that the velocity stopped, so it was 0 meters per second. Plus second car, 2 kilograms, same size, plus times, we don't know. We don't know that velocity, so we just leave it as v. So this is going to equal to 0 plus 2v, or just 2 times the unknown velocity. And now again, because momentum is conserved, these two guys, momentum before the collision and the momentum after the collision, are going to be equal. So we can set that equality. 10 kilogram meters per second is equal to 2 kilograms times the velocity. And that's easy to solve. Divide both sides by 2 kilograms, and we end up with 5 meters per second equal to the velocity. So we can go back up here and we can say this car afterwards was moving 5 meters per second. And again, we can compare. In this case, the masses were equal. The initial car came in at 5 meters per second. The second car was stopped. First car stopped. Second car left at 5 meters per second. All the momentum was transferred. So let's look at this one more time, knowing that we know about the math. All of the momentum is transferred, so the initial car comes in at 5 meters per second. The other car should leave at the same speed when it gets all the momentum of the initial car, and we notice what happens. The second car leaves at the same speed that the first car came in. All the momentum was transferred.